All right, we're back for part 2, MCT4C, day 14, lesson 2.4. Example 2 is, we don't have to state any of this stuff, domain, range, amplitude, no, we just need to sketch it. Now, this one should look immediately intimidating or strange. We're used to seeing two sets of brackets here, like this one, right? There's a bracket, and inside is the phase shift, and outside is the B value that gives us the period. And that was the case when we had the general one, right? It has to be in this form for all of this stuff to be true. See, two sets of brackets. So this one, our last example, looks weird. So first, we must make it look like the form that we're used to. Now notice that there's no A value, there's no C value, there's no axis out there. So we want to make it look like this. Right? Two sets of brackets, because then this is the value that affects the period, and then this is the phase shift, and we're all good. Now how do we do that? Well, how do we get brackets? Well, we got to factor, believe it or not. We have to factor that out. So it's not that hard once we see it. Now the problem is, are you going to remember to do this on your homework, or are you going to mess it up? Well, hopefully not seeing the double brackets in there might mess you, might make you think to factor it. So I'm going to take the 2 out front. Now what's left inside the brackets? Well, 2 into that, I'm just left with x. 2 into 90 is 45. And then now I can see what the period's going to have to be in the phase shift. So here, the B is 2, so I got the period is 360 divided by 2, which is 180. More importantly here is the important points, right? The important points are every 90 divided by 2, every 45. Now, that's kind of strange because, and we'll talk about this very soon, because 45 doesn't quite fit in with the way that we set up our scale. And we saw this before, but it is a bit of a hassle, right? Our scale is every tick is 30 degrees. So what's 45? We'll think about that in a second. Again, here, our phase shift, opposite that you think minus would be left, but it's right 45. The question is like how much on our scale is that? And when I set it up, just like that. There's 90, there's 180, and 270 and 360. How much is 45? Well, one way to think of it, and maybe you got this right away in your head, some method. 3 ticks is 90, 45 is half of that, so that's 1.5 ticks. Another way to think of it is, 1 tick is 30, so half a tick is 15. If I wanted to go to 15s, then it's 3 of those, 3 half ticks. Oh, that's a tick and a half, isn't it? No problem. Notice that in this one, our amplitude and our axis, or our vertical shift, and that sort of stuff is all normal, right? It's all, this is normal. So even though we weren't asked to state it, that's going to show up when we do our graph. So the axis that I would draw would be right along the y-axis. I'm going to try and have a decent scale here, make this look okay. Maybe that'll be 1 and -1 there, just so we have a nice big graph. No phase shift, right? Or sorry, we do have a phase shift actually, don't we? The cos graph, would normally start here. No amplitude change, so it's not like I'm going higher or lower from there. It would normally start at 1, but I've moved it right 45, which is 1.5 ticks, we said, right? Every 1.5 ticks. So there's my starting spot. And that's how we decided that we were going to do these is by finding a starting spot. Well, right there. Coast starts high, moved right 1.5. And now the important points are every 45 degrees, every 1.5 ticks, like we discussed before. So every 1.5 ticks, I get an important point. High, middle, low, and the low is just the 1 unit because I don't have an amplitude change. Middle, every 1.5 ticks. See that 1.5 ticks? 1.5 ticks. 1.5 ticks. Middle, low, middle, high. And then now I join the points. Notice that there's going to be a little gap here, so I'll follow the pattern going back this way. Low, middle, high, middle, right? It's hard to make it not look like teeth. There we go. That looks pretty good. Y equals cos, and I'm going to put the original. Just before you go, you run off and start doing homework here, one thing I want to point out is this cos graph moved right a little bit. If I were to look at that, I asked you to give me an equation, no, not having this, and I just asked you like I did the other day, give me the equation of this. You'd think it was a sine graph, right? You'd think it was a sine graph that hasn't been shifted, right? This looks like a sine graph, the same period with the same b value too. Those two are the same graph, aren't they? It's weird when you're writing equations of trig functions that there are a lot of answers. And to say, well, you know what? I thought it was maybe a cosine graph that didn't start there, but it started there. Or it was a cosine graph that was flipped and started here. Right? Started at its minimum instead of its maximum. There's an infinite number of equations that work here. So, yeah, so there. Done.